Okay, assume you've read and worked the problem if you're watching this. It's a pretty straightforward question today. It shouldn't be a question as to what to do. It's a matter of do you remember how to do it. So let's jump in and find the area of R. Well, area is top minus bottom, and we're going from 0 to 1. So it's x e to the x squared dx minus a negative, so it's plus 2x. Oops, don't put the dx in just yet. I'm going to in a minute. Dx. Top minus bottom. Now I kind of started to do it there, but I didn't want to lose you. We do need two different integrals because this first one needs substitution, but the second one does not. So that's why we need to split them up. Okay, so u is x squared, du is 2x dx. So I have 1 over 2x du equals dx. 0 becomes 0. 1 becomes 1. So in fact, it probably wouldn't have mattered if I didn't split it up on this one, just because that's a nice coincidence there. Okay, so I end up getting 0 to 1. Let's see. X e to the u times 1 over 2x du. Those x's will reduce. So I'll have antiderivative 1/2 e to the u. Plug straight back in there. So I have 1/2 e to the 1. Minus 1/2 e to the 0 is 1. So I just have minus 1/2. Okay. Let me finish this other part. So that's just x squared evaluated from 0 to 1. Let's get 1. It's plus, remember, so plus 1. So my final answer is 1/2 e plus 1/2. And that was worth 3 points. So I think that's a pretty straightforward 3 points. Okay, part B, it says if we rotate about y equals -2, which actually it's not very accurate here because this is the line y equals -2x. So if I plug in 1, that's actually the 0.1 -2. So I'm just going to kind of draw it. It's actually right there. Okay. So when I draw it, pretty bad at drawing that. It's going to look like that. Now remember, we're revolving around a horizontal line, which means you're with respect to x. However, we are not revolving about an axis, which means we have to add or subtract a constant. Okay, so we do have a big hole in there, so we need an outside and an inside. Pi r squared, pi r squared. Okay, so our outside, remember, go to the original, goes from here to that curve. Now remember, this distance right here is 2, right? It's a distance. Don't be worried about the -2. It's a distance. 2 plus the function. So that'll give me 2 plus that function x e to the x squared. Same for the inside. 2 plus that function. Oh, which is minus. So you can put plus -2x. Doesn't matter. Okay. We're still going from 0 to 1. I'm going to take the pi out. So I have 2 plus x e to the x squared minus 2 minus 2x squared dx. And I said right, but do not evaluate. That was worth 3 points. 3 points. It breaks down 2 points for the integrand, 1 point for your limits and constraints. Okay. Part C, once again, right, but do not evaluate the perimeter. Let me erase some of this here. Now, part of the perimeter is pretty darn easy. There are 2 linear pieces. So I have this linear piece and I have this linear piece. Okay. So right away, I know this distance is 2. That's kind of nice. Okay. I need to find this distance. Well, that's not bad either because I know this is 1. That's 2. Can't I use the Pythagorean theorem to find that? Right? 1 squared plus 2 squared, square root of 5. Okay. And then I need this. Well, that's just plugging in 1 to your function. So if I plug in 1 to my function over here, get 1 e to the 1, that's just e. Okay, so my 2 linear pieces so far are e plus 2. That's this one right here. That's my vertical piece. Plus square root of 5. Okay, so I've got my other linear piece. Now I need that curve. Well, that's just arc length. Now you need to remember the definition of arc length. We're going from 0 to 1. Square root of 1 plus the derivative squared. So I need the derivative of that function because that's the curve I'm talking about. So when I do the derivative product rule, first, derivative of the second, little chain rule there. Derivative of the first is 1. So my derivative is actually 2x squared e to the x squared plus e to the x squared dx, right? Remember 1 plus the derivative squared. Once again, you have to know those definitions because this was a pretty straightforward question if you remembered arc length. That was worth 3 points as well.